Hello class. So today we're going to learn about the Pythagorean theorem. Before I get started with the Pythagorean theorem, I actually need to show you a little bit about square roots because you're going to be using the square roots at the end when you solve for the Pythagorean theorem. So we'll just take a little bit notes on finding the square root. Okay. So this is finding the square root. So this is fairly easy to do. So a couple things you need to know is that we have this symbol, and this is known as the radical sign. Okay, and inside you always have a number. Okay, and sometimes that number is what we call the radicand. Okay. Sometimes the numbers are perfect squares and sometimes they're not. So I'll show you today what perfect squares are. So you have a perfect square. Now let's say, here's an example. Okay, you got example 1. And let's say I give you the square root of 16. Here's the square root, and we got 16. Okay, there's always, by the way, there's always here an imaginary number. Imaginary meaning it's not there, and that number means 2. So what that means is I want to take out pairs of 2's from this square root. So I look at 16 and I look at the factors of 16. 4 times 4 would end up giving me 16. Okay, so if I leave this in the square root, that means I now take out of the pair because of this imaginary 2. So I take out the pair, and my answer would end up being 4. Okay, so here's my answer to that once I've broken down square root of 16. Okay, the same thing goes if I had, let's say, the square root of 4. Okay, I take out pairs. These are 2 times 2 is 4. So if I say this is in the radical, take out the pairs, my answer would end up being 2. Okay, I now simplified this square root. Let's see another example. Example 2. Let's say I had the square root of 49. Okay, again, we want to go ahead and break out 49. What factors make 49 is 7 times 7. Okay, remember this is all still in the square root. And then your answer, once you simplify, would be 7. Okay, so that's finding the square root. This is how we can find the square root. So at the end of the Pythagorean theorem, you need to go ahead and simplify the square root, and this is how you would do it. Okay, so now let's go ahead and take a look at the Pythagorean theorem. Okay, so I'm just going to go ahead and move this one over. And we'll start with Pythagorean theorem. Pythagorean theorem was invented by, and you should have seen the worksheet by Pythagoras, who was a Greek mathematician. And he decided that he wanted to look at right triangles and figure out how right triangles actually work. So he ended up creating this formula, which we know as the Pythagorean theorem. Okay, the formula is a squared plus b squared equals c squared. You might have heard this before. Okay, so a squared plus b squared equals c squared. And the Pythagorean theorem only works with right triangles, and right triangles typically look like this. Here's your triangle. Okay, and most of the time they'll have this little indication that this is a right triangle. And what does that mean? Is that this is angled at a 90 degrees. Okay. But in the Pythagorean theorem, you have a couple things that the right triangle indicates. First of all, we'll see that the right triangle, sometimes this little triangle is not there, but you can still see that it's a 90-degree angle. But you have other things that we can label. First of all, we can label the sides. These sides here, this one where the right angle is, this is a leg. And this one here is also a leg. Okay. This one right here, this is the longest side. So it has a couple names. Being the longest side, it's also called the opposite side. And it is also known, most definitely known as the hypotenuse. So when we label these, this one's usually C, this one's either A, and this is either B. These two could be either way. Meaning I could have B here and A there. It doesn't really matter with this one. Except this is the most important. You have to know that this is the longest side. And it's always opposite of the right triangle. Okay? Another way to show that is I always like to draw a little, let me show you, a little Pythagorean man. So let's say I had my right triangle here. Okay, here's my right triangle. How do I know which one's the longest side? Well, I draw my little Pythagorean Theorem man. Here's the body, here's the head, and these are the legs. So we'll know this as a leg. Here's the other leg, and this would be the hypotenuse. This also really works well when you have the triangle that does not have or does not show the right triangle. Okay, so sometimes you might have something that looks like this, and they'll label which one's A, which one's B, which one's C. You got to figure that out. Draw your legs, draw your little guy, and you'll know this is C, this is A, and this is B, or these two vice versa. Okay. Now, knowing this information, we're now going to go ahead and take the formula, take the triangle, and mesh it together and find for the missing sides. Okay, so let me move this around. So with the missing sides of the Pythagorean theorem, again, the Pythagorean formula, and I should say the Pythagorean theorem formula, or the theorem, is a squared plus b squared equals c squared, right? And so let me say I gave you a triangle. Okay, and I need to find the missing side. In this case, I'm going to say B equals 5 millimeters and A equals 12 millimeters. Okay, and C is missing. Okay, so the hypotenuse is missing. Find the missing side. In this case, hypotenuse. Find the hypotenuse, which is the C. Okay. I'm going to go ahead and use this formula. I'm going to substitute information in that I got. So first of all, I have a squared plus b squared equals c squared. For a squared, I'm going to substitute it with 12. So I'm going to put a as 12, and I'm going to square it. Okay. I'm going to go ahead and put b as 5 and square that as well, because they have the squares. And then C, I don't know what C is, so that's the missing side. I'm going to leave it as C squared. You can put the units, or you can put the units at the end. I like to put them at the end, okay? So again, what we did is we substituted. Substitute numbers. And then we now multiply them out. So we got 12 times 12 and 5 times 5. So 12 times 12, you're going to get 144. And you're going to get 5 times 5 is 25. Okay. What you want to do is go ahead and add them. So multiply here. And now we're going to go ahead and add these two numbers together. 169 C squared. So 169, we're going to go ahead and now take the square of 169. Okay. So once we take the square of 169, we know that we have C equals 13. Okay. That should be our answer. Remember when I taught you earlier the square, this is what I mean. You're actually taking what 169 is 13 times 13. Take the pair and you get your answer. The same here goes for the C. You're going to take the pairs of the square roots and get them as individuals. So this is your answer. You can also say the hypotenuse is 13 millimeters, okay? The hypotenuse is 13 millimeters, all right?